Statistics can be incredibly useful when used properly. However, when used improperly, it can distort the truth and deceive. So in relation to graphical displays, here are some deceptive practices. The first one is called a baseline change. That's when the vertical scale does not start at 0, and that's what happens here in this graph on distracted driving and accidents. We see cell phone caused 12% of the accidents from their data, and music caused 8%. Well, it looks like 12%, that bar, is twice as high as 8%. So it looks like there's twice as many cell phone accidents as music, when that's not the case. 12% is not twice as big as 8%. Same thing with grooming here. That's 6%. Looks like cell phone accidents are 4 times as much. 4 times 6% would be 24%, not 12. So that's a baseline change. Here's another deceptive practice. This is altered scale. So notice this goes up 4% and then 4 to 8, but then it's 2, 2, 2, and 2. So they've changed the scale here. This is a difference of 2%, but then this is a difference of 4%. It's not consistent. So again, you get these distortions. Cell phone at 12%, music at 8%. It looks like 12% is twice 8. It looks like 12% is 4 times as much as 4%. So again, we want to have a consistent scale on the vertical as well as the horizontal. And then you can also have a squaring effect where you change more than one dimension. So we look at here the passenger accidents. This is same data, and we see that this bar is not only higher than cell phone, but it's wider. And in fact, if you compare the passenger distractions to the music, it looks like this bar here. It looks like almost 4 of those bars would fit inside the bigger one. So it's making 15% look like it's 4 times as big as 8%. So again, that's deceptive. You're not properly portraying the data. So those are misleading descriptive statistics in graphical displays. Here's another example that could be misleading. You're looking for a home in a city near your employer. A local realtor tells you that the average house, quote unquote, will cost you $200,000. City assessor's office tells you that an average house costs $250,000. Why is there such a big difference here? Well, with housing prices, they tend to be skewed data. Usually there's a few houses that are very, very expensive, and they pull the average up, so it's not representative here. So housing data, house prices here are skewed. And I would imagine that they're actually skewed to the right, to the high side. So the distribution of housing prices looks something like this. And you've got those few very expensive properties that are pulling that average up so that the average is higher than the median. So here the mean will be greater than the median if you're skewed to the right. And it probably is the case then that the local realtor is quoting the median and the city assessor is quoting the mean. But they're both calling it an average or typical house. So our mean here could be the $250K and the median could be the $200K. And if you're not told that your data is skewed or you're not told which measure you're using, if you do that on purpose, that is a deceptive practice. Now, I'm sure that a lot of deception happens inadvertently, but especially in the age of the pandemic, that has not been the case. People will portray statistics improperly, or they'll only use data that supports their case.